Okay, right. So let's kick off the third session and final session of this morning. We've got 4 speakers now, all who've got extensive experience of working in the sector. All of you've got experience of delivering projects of the kind that we've been discussing so far this morning. And we're going to start with Matthew Black from Kenza. We're going to then go on to Dave Pearson from Star Renewable Energy. Then Andy Yule from Vattenfall is going to talk about heat networks from their perspective, and we're going to finish off with a more visionary perspective from Ben Carter, who is going to tell us a bit more about their Heat Vision 2030 project. So not to delay any longer, Matthew, would you like to crack on, please?
Thanks very much, John. Thanks for that. Next slide, please, Lynn. Yep, so my name is Matthew Black. I work for the Kenza Group here in Scotland. So just to give you an introduction to who Kenza are, the group is made of 3 companies. Firstly, Kenza Heat Pumps, who are the UK's only manufacturer dedicated to ground source heat pumps, and we've been established since 1999. We have our head office is in Cornwall, and we have a new factory there now, which produces around about 25 heat pumps a day. We manufacture there that are shipped out all over the UK. Kenza Contracting is the part of the business which I work for, and that's a specialist ground source heat pump installation business. We're really focused on social housing. We've come from social housing retrofit and also do a lot of social housing new build projects, and also some private sector work as well, and we started doing a lot more non-domestic recently as well. Next slide, please, Lynn. So to talk you through the concept of the systems we install, I just thought I'd run through a few case studies. So this is a project that we installed way back in 2018. So this is in Enfield Council in North London, and this is 8 tower blocks, 8 blocks that all had electric storage heaters in them. And we drilled 96 boreholes and connected them together and put an individual heat pump in each property, and that has saved the residents loads of money, and it saved a bunch of carbon. So what we're doing there is we're drilling down typically around 200 meters into the ground, and next to the tower blocks was a play park and a lot of green space. So we took over that space while we drilled that infrastructure into the ground and then reinstated the work there. So if you go there, you won't actually see anything because all the boreholes are in the ground and the heat pumps are in each individual property. Next slide, please, Lynn. This is another similar project that we are just finishing off just now, and this is for tower blocks in Sunderland, so 7 tower blocks, 364 properties. This is replacing gas, so there's currently gas infrastructure there, but the landlord wants to remove gas from these tower blocks completely and replacing them with a ground source heat pump. And in the photograph there, you can see the ground source heat pump on the shelf in the foreground, and in the background in a SunAmp hot water battery. Something quite interesting about this project is that instead of a conventional ground source, what we're doing really is this is really a water source. We are pumping water from an underground aquifer and capturing that heat through a plate heat exchanger in the bottom of the tower blocks. Then that heat is being, that low temperature heat is being delivered to individual heat pumps in each property. Yep, so that's a gas removal program that we're currently just finishing off in Sunderland. Next slide, please, Lynn. This is some other projects that we've been doing for Together Housing. So they started off with a small pilot project, and they were so impressed with that they've decided to roll out ground source heat pumps across 1,000 units of their housing stock. So that'll be replacing night storage heaters and gas boilers. So the residents will save up to 45% on their running costs. The project is eligible for the non-domestic RHI, and that is not metered. It's just purely based on the EPCs, and that is for existing low-rise housing, but also tower blocks as well. Next slide, please, Lynn. There's also a couple of other projects I'd like to tell you about. So we've also just installed a new build project for Bristol City Council. That's 130 housing units. There's actually a webinar about that project on our website. So if you go to Kenza Contracting website, there's lots of case studies and webinars there, so you can find out more about that there. You can also find out about our Oxford Energy Super Hub project, which is pretty exciting as well. And just to go on to what stuff we're doing in Scotland. So this is a new build project that we've just completed. It's a very small project. It's just 24 new build apartments in an old converted school, and this is in Grampian. So there's granite there, and it was quite challenging geology, but we drilled it fine, and we drilled through. So the first 50 meters of the ground was built up a big round granite boulders. So we got through that to the bedrock, and then drilled straight through the granite using air compression drilling. And that project is now complete, and they're just finishing off the internal works for the apartments now. So that's one we've got in Scotland. Next slide, please, Lynn. So other projects in Scotland, we've got quite a few in development and that we're designing out at the minute. So some sites in Glasgow on the south side, in the city centre of Glasgow, so in the West End and the East End. So these will be sites that are gas connected, but they don't want to use gas, they want to go ground source instead. And some of these are in quite urban situations. So these will be high-rise apartment blocks with communal bits of ground nearby that we're using for new builds. Some sites in Edinburgh and in the northeast. So it's not, a lot of people talk about rural off-gas properties, but lots of our projects are in urban on-gas situations and even in city centres as well. Next slide, please, Lynn. So this is what's one of the products that's very unique to Kenza is the Kenza shoebox, and it's the smallest ground source heat pump on the UK market, really. And this means that we're able to install these in flats, in denser housing and affordable housing, because it could just sit in a cupboard with a hot water cylinder, and it does all the space heating and hot water, so there's no electric backup, no fossil fuels at all. So that's our biggest selling heat pump, and that's what we do in a lot of our social housing projects. These are connected to the consumer board in each property, so there's no metering and billing. The occupant just pays for their usage through their standard electricity bill. So the operator of this, be it a local authority or housing group, they don't need to set up an ESCO, they don't need to contract with any residents, they don't need to do any billing. So that's quite good. Next slide, please, Lynn. So a lot of people say, well, why ground source? Isn't it more expensive? Is the first thing they'll say. And if you could just click again there, please, Lynn. And yeah, generally speaking, not always, but generally speaking, it will be a higher capital outlay than gas, electric, or air source. We need to drill holes in the ground, and so generally speaking, it is. Next slide, Lynn. But the advantages of that is that ground source considerably outperforms air source, especially when winter. If you imagine winter in Scotland, it is when people require heating the most, and because of that higher efficiency, that has several impacts. It has impact of higher CO2 emission savings from these projects, lower running costs than air source. It also has an impact on the grid. So there was a recent study on from Canada that said that ground source results in a 50% reduction in peak grid capacity requirement compared to air source. So it can affect the grid infrastructure that needs for these systems as well. These are ground source heat pumps. They're located inside, they're not outside. So the heat pump units last about 20 to 25 years. So if you take a 40-year life cycle approach, you'll be maybe installing your second ground source heat pump by year 40, but you will have replaced a gas or an air source system perhaps 3 or 4 times in that period of time. And the boreholes are there. Once they're installed, they're there for the lifetime of the building, over 100 years. So that's why it's a low operating cost to the landlord. Annual servicing requirements are low as well. No metering and billing, as I've said before. There's no external equipment to look out. So there's no energy centre. There's no boiler to fuel. So very low cost to the landlord. Enhanced building and fire compliance. Low running costs to the residents, very simple controls, and the lowest CO2 emissions of any heating system out there. So that's why people are installing ground source. Next slide, please, Lynn.
Matthew, we're on time. We're out of time pretty much. So can you just wrap it up?
Well, that's good.
Basically now.
This is my last slide. So if you want to look at your ground source, you have to look at the housing stock assessment and build the business case internally. Get in touch with us and we can help you look at any sites, looking at the 40-year lifetime cost analysis, the cost of carbon, local air quality, running costs to residents, and future-proofing housing stock. And there's some funding that we are expecting more funding announcements later this year. And it's good to have projects ready to accept that funding. So please get in touch with me. Last slide, please, Lynn. Please get in touch with me. Have a look at our website. Lots of case studies in there. And please feel free to get in touch if you'd like to know more about ground source heating.
Thank you, Matthew.
No problem.
Dave, would you? Can I just pass straight over to you, please?
Thanks, John. Okay. Next slide, please, Lynn. I'll rattle through these. So we've heard quite a bit about the threats and so on, and some of the opportunities. So a quick take on the water source aspect of this, but you know, let's see where it goes. Lynn, slide, please. 2009, I checked the date of this cartoon that was used. And it's still true. We're still not quite past this if it's a big hoax, but I think the aspects on the right-hand side certainly have been touched on by many of the speakers already today. But it's a nice little reminder of it's a very broad topic. Slide, please, Lynn. And a more recent one, terrible times we're living in at the moment. COVID-19 still with us, recession kind of forgotten about, but I'm sure it's about to happen. And climate change looming as an even larger tsunami beyond that. So lots to do. Slide, please. And every year, greater and greater bodies of evidence. So I hope we're now moving past any sort of debate that there is an almighty challenge facing us. Slide, please, Lynn. So a graphic from the European Heat Pump Association from a couple of years ago, but really a very broad opportunity. We hear lots of work around roadmaps and so on. I think it's always good to decide what destination you want to see. And for me, you could pick any of these as the most important to you personally. I think as we're trying to work our way forward from COVID and a recession, job creation is a big one, less imports is a big one. We want a much broader range of devices on our grid that help balance the grids, and heat pumps are very flexible. You can switch them off very quickly. But of course, clean air has also been mentioned, and John has mentioned the case of Deborah, Kissy Deborah, sorry, in London in 2013, and that really brings it very much home, particularly anybody that's got any relatives with breathing challenges. Renewable energy is the sort of banded topical topic. but it's really very broad. So next slide, please. The challenge, I think, in any discussions around clean heat is that we use heat in all our buildings, but our buildings are all very, very different. You could probably come up with 9 or 10 different segments, and so I'm certainly always advocating a segmented approach to this. What we should do for a brand new build, not yet built property, is probably not necessarily the same as what we should do for a low density domestic property or an industrial aspect. Interestingly, we're seeing heat recovery and whiskey distillation as a key opportunity. Instead of throwing away all that heat and creating a challenge on the water course from the cooling systems, why not recycle the heat? Not the topic of today, but something we've been working quite hard on. High density commercial is probably the area that we're looking at most. The centre of cities, a small picture of Dumfries, but it could be Perth, it could be Glasgow, it could be Edinburgh. Any city has got a very, very high density. And then also there's recent build. Let's not forget that in the UK we're building 200,000 properties per year, and that means last year there was 200,000, the year before that there was 200,000, and so on and so on. If we're going to get to 600,000 heat pump installations per year, let's pick off the easy ones. No mention of how many big heat pumps, but that's just fine detail, I'm sure. So break the segment down and you get a much better view. So my Venn diagram on the right hand side is really my view of what this looks like. You must have a heat source. Clearly there's a heat demand and you need that return on investment. The technical bubble used to appear in this when I gave a slide like this many years ago, but I think it's now accepted that you can use a heat pump for pretty much any building. Quite clearly some buildings are more suited than others, but I absolutely refute that there are buildings that cannot be heated by heat pumps. So I've taken the technical capability away from that. Next slide, please. So for those not familiar with the heat pump, it's essentially a fridge, not running backwards as some people say, but we're just looking at the warm bit rather than the cold bit. What we're doing is taking something and cooling it down. Could be air, could be water, driving the compression cycle with electricity, and all that heat from both the electricity and the low-grade heat, the ambient heat, ends up as usable heating, and typically in a ratio of about 3 units of heat for 1 unit of electricity. Next slide, please, Lynn. And so to a bigger one, this was the case that was mentioned earlier in Dram. In 2009, I first went there and we got involved in the project. They were already well on their way to doing a big heat pump, and we stepped in and said, well, what about using ammonia as the working fluid? It's environmentally not damaging to in a global warming sense. The alternative synthetic working fluid would have been quite dramatic, and 25% less electricity, and that's a biggie when you have such a large connected load for electricity. We won the project, came home and thought this was going to be so easy in the UK. We had the renewable heat incentive that the UK government had set up in 2008. Unfortunately, they had a mistake in it, which meant that there was no tariff guarantee up front. You had to spend your, in the case of Queen's Quay, that'll come to £20 million, deploy the whole system, and then turn up and ask for the support mechanism. And quite clearly, that's not the way that developers, public or private, think. They like a little bit more certainty. And so there were no projects typically using the RHI until that was fixed, and that took until 2018. So the first 10 years were the wilderness years, and then we started getting some traction on that. So next slide, please. So Queen's Quay, the famous home, John Brown originally, Queen Mary, Queen Elizabeth and QE2 were all built there. So big they had to extend the quay. You can see the little notch taken out at the bow of the ship. Sadly not there anymore, just the crane you can see on the left hand side, but the site has been cleared and redeveloped, and very proud of the fact that Western Bartonshire Council have taken a very, very progressive view on this, and effectively are saying let's be 2030 ready in what we're building. Let's stop building the wrong stuff. Just as a point of reference, we are still seeing new houses being built in the UK with gas boilers in them, despite everything that's been said by all the speakers so far. We haven't yet got to grips with stopping doing the bad stuff. It's like as I probably should. Lockdown hasn't been kind on me, but turning up at Weight Watchers with a pocket full of donuts, it's just not a brilliant plan. Next slide, please. So artist impression, but there's a lot more to see. The energy centre is now built. We've deployed two 2.65 water source heat pumps, each able to go up to 80 degrees and taking heat from the river, and some really interesting stuff that was studied in the earlier presentations, showing the huge capacity for this. This is the seawater part. It's actually the Firth of Clyde rather than the River Clyde, and some seeing the Atlantic behind it. We are not going to freeze that body of water by taking heat out of it, not by a long shot. Next slide, please. Next slide, please. Thank you. So it's built already. You can walk past and see the units. They're built. They're running. Some heat demand on the site already, but the network clearly is being built out as it goes forwards and hitting our performance targets. And so, you know, taking the UK electricity grid intensity of about 250, divide that by 3, and you get a massive saving versus the burning gas option. But the Scottish grid is even cleaner than that. I've seen cases where the south of Scotland is only 12 grams of carbon dioxide per kilowatt hour of electricity. Divide that by 3 and you get 4 versus 225 is a massive saving. I think it was about 98% lower carbon footprint than burning gas. And of course, has been mentioned already, no NOx produced when the heat pumps are running. Next slide, please.
Just are you near the end, Dave? Are you wrapping up? Perfect.
2 slides. So 2 things to say. Lots of really great data about the river capacity. The Clyde itself, and this is the upstream portion, it drains the 4,000 square kilometre area of the Upper Clyde Valley, and that gives us a capacity of about 200 megawatts. To put that in context, that's many multiples of what the city centre would need. And Ben Carter will speak more on Heat Vision 2030 later on. I'm becoming more focused on the policy aspects of this, and there's some interesting stuff at fairopoly.com about how do cities actually create a circumstance where buildings would want to use clean heat rather than gas, and that really is the hot topic, if you pardon the pun. So final slide, please, I think, Lynn. And click again, thanks. So, and one more time, please, thanks. And sorry, one final time. This is like Blockbusters and there we go, click right to the bottom, thanks. So it's about making them low risk, predictable, and focus on that ROI. It's about you know, creating a business model for this. The pent up investment appetite from what's called the long money, the pension funds, is incredible, but you have to give the investors a business model that works, and that effectively means inclining every business to switch away from burning fossil fuels to something cleaner and better and safer. So thank you for that. I'll leave it there.
Thank you, Dave. That's great. Some of Dave's content will be touched on with Ben Carter in 10 minutes, so we may come back to some of that. But Andy, would you like to crack on and have your 10 minutes, please?
Absolutely. So let's make a start. Next slide, please. So this is a bit of a corporate background and introduction to Vattenfall. Vattenfall are Sweden's state energy company, and we design, build, own and operate energy assets across Europe, Scandinavia and the UK. A large portion of those energy assets include district heat networks. We've got 1.8 million customers that we serve every day, and that number is growing. So my role in all of this is I'm lead development engineer, and I help move district heat networks onwards from a concept, initial point of contact, through to a design system that we can pass on to our delivery teams to build and then operate. Vattenfall's objective, their mission statement as a company, is to enable fossil fuel living within 1 generation. And because of that, all of the networks that I'm involved in the UK are all low carbon heat networks from the outset. Now, the thing about developing large scale district heat networks is that it's a reasonably complex thing to do. So I often liken it to trying to jump into a moving aeroplane. So next slide, please. Now, the thing about jumping into a moving aeroplane is that it's very difficult, but it's technically not impossible. Now, this guy we see here, Vince probably didn't wake up that morning, put on his wingsuit, go straight out and jump into that airplane. He did probably wake up one morning with the idea and the goal and the objective. And then what he'll have done is he'll have built a team around him with that shared goal, the shared vision, the resources that come from a partnership to make something that is very difficult look seemingly quite easy to do. So next slide, please. Now, in heat networks, we're not jumping into airplanes, but we are doing a big piece of large-scale infrastructure. So there are some commonalities. It's largely often driven by government strategy and policy. So back in the 60s, we probably had a government strategy and policy that said, right, we need to cross more rivers, and we're going to cross some more rivers, let's go and build some bridges. That's the way to cross rivers. The designers and the owners, operators of the Forth Road Bridge didn't probably go straight out and start pouring concrete. Next slide, please. They would have done a little bit of research first. So this is very similar to the energy master planning that Guy Milligan was talking about earlier. They've looked at the demand, tried to understand what that looks like in terms of volume, profile, how it's likely to change over the coming years. Once they know that, then we start to know a little bit about the capacity and we can start designing and developing our project. Next slide, please. So in heat networks, what we're talking about there is effectively demand. We really need to understand what the buildings are going to require. So this is a retrofit project we're looking at. We really want some heat meter data to understand how that building requires heat. So if you don't already have heat meter data, and even if it's not a heat network project you're considering, but any form of low carbon heating, now is the time to go out, make sure that's installed. If you already have it, now's the time to get out there and make sure that it's working. Next slide, please. If this is a new build opportunity, then what we're looking for is some quite well advanced data on what that new build opportunity looks like. So the size of units are going to be built, the specification they're going to be built to, and timing. When is heat required? This is information that allows us as Vattenfall to help start evaluating a project and designing and developing it. Next slide, please. It's also really important for us to have an understanding of how heat will be used within the buildings. Now, if I was giving this presentation 10 years ago, I would have probably said that the demand for heat in the building would influence the specification of the heat network. However, as I mentioned at the start, the heat networks that we're developing now are low carbon heat networks, and therefore they operate at slightly lower operating temperatures, predominantly around about the 60 to 65 degree mark. And the reason for that is that it allows us to integrate low carbon sources of heating. So the heat pumps that we've talked about already, recovered heat, waste heat, and it allows us to operate those heat networks efficiently and deliver low cost and low carbon heating to the end users. So they are lower temperatures than would traditionally be achieved by gas boilers, but they're not exceptionally low. They're not ambient networks or ultra low temperature networks. And it's our experience that most buildings can be heated with temperatures of that range. And it's not a huge technical challenge, but it is a little bit more of a mindset challenge to overcome. So next slide, please. So this is the really nice sequential waterfall diagram. We start with master planning, we end up with a fully built and operational network, and then we can all leave early and go down to the park and play. However, reality isn't often like this, so next slide, please. This is a little bit more like developing a heat network. Lots of ups and downs and unexpected challenges. However, the main difference between a heat network and snakes and ladders is that developing heat network is not a game of chance. So having the right partner on board, getting the right technical advice, working with the right suppliers and energy companies such as Vattenfall, we can help identify where the snakes are early on in the game and also highlight where the ladders are. So we get to the end in a much smoother manner. Next slide, please. Get to the end, and this is one of the things that happens. So this is our lead engineer, this is Selene, and this is her on-site at our project in Brent Cross, overseeing the installation of district heat pipework. Next slide, please. Right, big disclaimer that comes at the end. So some of you may have been thinking, why did they choose the Forth Row Bridge? Famously, a project that the bridge broke. The bridge had stopped working every time it got windy. So is this a really good example of infrastructure? Now, it might not have been a perfect bridge, but in my point of view, having a bridge there for 50 years, instead of having to continue to cross the Forth by car ferry, is a much bigger success. And so it should be judged on that basis. Ultimately, it did need to be replaced, and we upgraded it with the new Queen's Ferry crossing. So the comment there and the important message is not to delay, not to spend that 50 years doing nothing, but to make a start now. There is no one day where we wake up and we've got all the information we need to make the perfect district heat project. But it is really important that we make a start now. And in terms of importance, what we're talking about isn't like an end of year balance sheet report or an energy and climate change report at the end of the year. We're talking about climate emergency, and we're talking about ensuring that we have a planet that's habitable for future generations to live in. And I think that future generations quite rightly are judging us on this. And I really hope that over the next 10 years, they are really proud of what we achieve. So next slide, please. That's all I have to say, and I will pass you on now to Ben Carter.
Thank you, Andy. And thank you very much, John, Julie, and Lynn. Really, really great set of presentations. So yeah, I'm head of market development at Mini-BEMS, but I'm really here today, this morning, this afternoon, to talk about the work of Heat Vision 2030, which is a project that has been developed by the firms and organizations you can see there in the logos, with the objective of doing a little bit of homework about trying to figure out what will make heat networks a success in the UK market context, to try and provide some kind of vision, to instill confidence in ourselves, in the wider market, in the value chain and the supply chain, and hopefully sort of give a sense of ambition and help increase people's ambition with what can be done with the ultimate goal of accelerating heat networks. And what we did is we investigated the challenges and opportunities mainly within densely populated urban areas. We've seen a lot of reasons why that would make a lot of sense over the course of the previous presentations. So we brought these partners together, and it's a really nice mix because Greenspace helps us understand the geography of the locations, integrating the place and the people. Comsoft, you'll see the outputs that we developed with the Comsoft tool in a moment, helped us to design, explore, and articulate the options within that local context for heat networks. Star Renewable Energy and Mini-BEMS are two examples of the technologies that exist today that are suited and that can enable those decarbonization goals. And Vattenfall is the developer that is able to really identify and understand whether the mix of legislative regulation and market conditions is right for it to deliver. Next slide, please. Thanks. So I'm not going to go much into this. We've actually seen in the previous two presentations a really good identification of what the problems are. And ultimately, I think pain does give meaning, and it also provides the platform for building a positive case to be motivated to pursue a safe, secure, and sustainable energy system. Next slide, please. And yeah, we all, I think, have a decent idea of how we got here in the first place. This is a lovely picture of the steam-driven Manhattan heat network, a great example of the way we treated energy in the past, and indeed where we've come from with respect to heat networks. And there is now a consensus grown that we can move towards a large-scale transformational, holistic and integrated approach to energy systems and to heat networks. Next slide, please. So, yeah, if you could click once, please. Yeah, this is a sort of a very simple representation of a little bit where we are with heat networks today. In the very top left hand there, that's a little white block that represents the development at Queen's Quay. And it's representative a little bit of how heat networks are. This is Glasgow and the greater area. It's fragmented, it's a piecemeal approach. And that's, I guess, inevitable when we're incorporating a new technology. That's been okay until now. It's given us the opportunity to learn, but now we must move to the delivery of large-scale and long-term solutions. And I think we've had a great insight into how that can all be knitted together. Next slide, please. Yeah, and to reiterate that point about, well, what needs to underpin that? It needs to be low risk, predictable, repeatable, and there needs to be a return on investment. If you could click twice, please. Yeah, so imagine if we take these little hubs, these small beginnings, and we start growing it. That's what we need to find. What is the set of circumstances that allows us to go from fragmented to larger? And if you click again, and from there, really beginning to bring these bigger zones together, so that we've got the leveraging of the initial anchor loads, tethering them to other buildings, and then into whole city blocks, and then into whole city centres. And that's really what the ambition and the vision that we were trying to see if we could develop or come up with respect to Heat Vision 2030. Next slide, please. So there's consensus that we can take a whole systems approach, but there's barriers or issues that I guess we need to try and be upfront about, and that's another part of what we were trying to do at Heat Vision 2030. What were the key sticking points or issues that maybe are being discussed or aren't being discussed in as much detail as they might? Next, if you just click once, please. Actually, yeah, click. I think you have to click 7 times actually. And here they are. Offtake surety. Ensuring that there's going to be a big demand for the heat. Just once more, and that's perfect. The electricity price we discovered is fundamental to making low carbon heat networks work. We've seen why ground source heat pumps, river source heat pumps, etc., all use electricity as the core primary fuel. That play between heat price versus gas price, the public engagement. Where is the groundswell of understanding of what a heat network is, why it's great, and whether indeed people believe that it can be great? Where is that? So getting the community involved and stakeholder buy-in. That's the supply chain, that's the local developers, the councils, all the different people that need to be part of this. Yeah, so we need to address all that, and we need to try and turn that into a real vision for the future. Next slide, please. Yes, so this is what we did. We created a model using our own knowledge, our own understanding, and it was based on this idea of, could we turn Glasgow city centre using the heat from the River Clyde into a complete heat network? So we built up a model. We assumed a 60-year lifetime, 100% uptake, so total offtake surety for the investor, a low but acceptable IRR, which is an indicator of suitability for investment. And we found that we were able to heat 1,300 odd buildings, but we also were able to incorporate the costs involved: £1.6 million per megawatt of heat pump, £2,000 per metre of pipe work. And we added that into the mix of a relatively, well, with 2 scenarios, a grid electricity price of 10p, or sorry, I should say that a grid electricity that allows us to deliver heat at 10p per kilowatt hour, and then a lower local private wire price that allows us to deliver heat at 4.5p. Next slide, please. And this was the vision that we came up with. We came up with 74 kilometres of pipe work, 49, almost 50 megawatt hours worth of river source heat pump, 140 gigawatt hours of heat sales. So we were able to demonstrate that it is possible. You know, the technology is there, it's feasible. It's whether the economic model, the business model, the market conditions can deliver. Now we estimated that the cost of this is just the sort of the principal city centre of Glasgow, would cost some £250 million to develop. Next slide, please. And yeah, part of the problem there, of course, is that these are older buildings that need a lot more heat, and that is one of the big challenges. 80% of buildings that exist today will still be around in 2050. So there's the new build, which is the easy pickings, the recent build, which is ones that should be definitely converted over to zero carbon. Then there's the big chunk of 20, 30, 100-year-old buildings that need to be delivered as well. So broadly speaking, we were able to come up with a model that said, yes, it's doable, but we need the right conditions. Yes, we're able to deliver 31.5 kilotons of carbon dioxide equivalent abatement per year, but we need to be able to get there. And given that the regulations or the goal and the ambition from the UK and the Scottish Government is such that the private sector will take the brunt of this investment, we also need to be explicit about what challenges are there, because we believe that there's going to be a need for some kind of public or social input into this to attract the sector, the private sector funding. We're going to need to have a good idea of what the risks are, and we're also going to need to accept perhaps some slightly difficult things. But let's remember about pain, no gain. The heat price may never be below gas, and perhaps certain building users or all building owners may not have the choice of sticking with gas. Maybe they'll have to move to something low carbon. Next slide, please. So yes, there's some great opportunities there, still some big unknowns that we've looked at, and we need to keep that debate going. A lot of it's understanding the local conditions, and that's where it is so important to have a local understanding and build up a local consensus and drive and vision for what can happen in any given one of these places. Next slide, please. And just to remind, as always, prevention is better than cure. According to an article in Nature, for every ton of carbon dioxide that we emit today, we've got a social cost of £350 stored up in the future, whereas this project would have a cost of per ton abated of £150. So there's a big, clear economic case. Next slide, please. Still, this is just to highlight that our work also raised a whole bunch of other questions that still need to be looked at, and it's part of this broader conversation. And really, just to finish off, to say the next two slides, if you just go through them quickly, is a sort of result of those questions of more of the questions that we realized that we needed to ask and discuss. And we held a roundtable on Friday there that's going to feed into our next white paper about the ideal conditions to deliver heat networks. And that's hopefully something that all of you will be able to use and share. Sorry, yes, if you could go to the next slide, please. This is just very briefly the beginnings of what that roundtable delivered. Some really interesting ideas, and a bit of a plug really to let you guys know that we'll be incorporating that thinking into our upcoming white paper. And you can just skip the next slide, and that's me. Thank you very much.
Thank you, Ben. That's great. Really useful. It's interesting, as part of this work, we have all of this data about heat demand for all the settlements, but and what sort of dent you could make in if you could transform one of the settlements into a totally low carbon heat centre. And of course, choosing Glasgow to do that would make an enormous dent in Scotland's overall low carbon heat sort of capacity and and offsetting current carbon emissions as well. So Glasgow, because of its size and its heat demand, is enormously influential. So it's a great place to start, and I would dearly love to for Glasgow to take a vision as the first city to decarbonize completely. And if we could take a big, bold vision like that and look at a scale like Glasgow in terms of demonstrating to the rest of the UK what could be done if we try and decarbonize a whole city, and what the challenges would be. But it would certainly be something that I would hope our COP26 colleagues would be keen to look at. So so that would be my big vision, is let's do it for one city, and then let's take all that learning from one city and put it into how do we roll it out to a fast follower network across the rest of the UK. So just while I remember, we have the heat in building strategy that was mentioned a couple of times, is currently at consultation phase. And Drew has asked me just to make sure that I plug to you all that there is a closing date on that consultation of this Friday, the 30th. So please, if you're interested in this area and you want to feedback, it's a chunky document, but they're very, very keen to get feedback from all of the stakeholders involved on that area. So please take some time to at least have a look at that. I have a general question for some of you involved in this whole area. Matthew was talking about generally doing things on a smaller scale, perhaps for social housing, whereas Dave and Andy have been talking about, and in fact Ben has been talking about working on a much larger scale. So is there a place for both small scale and large scale heat solutions? In effect, are they competing with each other, or are they actually compatible with each other? So that's my question. To maybe Matthew could start. Do you see yourselves competing, or do you see yourselves being complementary?
Definitely complementary. I don't really see any competing really going on. I think certainly from Kenza's point of view, we see our solution as infinitely scalable, so it can be done in small clusters or on a larger scale, and can be done in a variety of ways. So yeah, I think definitely complementary, and using different energy sources such as waste heat, providing cooling, using river source, using ground source, using open loop. I think this is all very achievable and all very complementary.
How big a scale could Kenza potentially go in terms of if we wanted to scale up a Kenza solution to a whole neighborhood or a larger area? Is there scope for doing that?
There is scope for doing that. It comes down to practicality and things like the cost of doing pipe runs, and it really gets down into the groundworks of doing that. You know, there's no point in spending money on trenching lots of pipework everywhere if you can do smaller clusters which give it the system more diversity. But then it's very on a case-by-case basis on how you would see that. I would suggest that smaller clusters are sometimes better.
Dave, you've said in the past that we should be looking at converting whole settlements. Is that still your view?
I don't think all the data is there, John. I think you know, the power supply is an interesting one, and what happens. What we've looked at in the centre of Glasgow is that the more centralised you get, the more available capacity there is in the power grid, or for that matter, bringing in a parallel grid to supply a couple of, you know, as the example we've done. And it was just a first pass to try and stimulate somebody to go and do the work again on a more involved basis. But 4 or 5 new power connection nodes is one proposition, and it really comes down to what the electricity grids say. The challenge at the moment is that the electricity grids aren't effectively being steered by the government to say this is what the solution looks like, go and make it viable, i.e. go and reinforce the grid where you need it. Now, whether that's a building by building or a street by street or a district by district, nobody has actually said that yet, because we're still sitting deciding what the policy is going to be. Are we going to just do nothing? Are we going to have a hydrogen-based solution? Are we going to have a heat pump-based solution? It absolutely will come down to different horses or different courses. You know, the archetypes of buildings are very, very varied, even across one city. Anybody that wanders around, just look at the difference in the buildings across something like Glasgow. So there's a space for anything, providing you're not burning something in the city centre, in my opinion.
Andy, do you want to comment about Vattenfall's view in terms of the scale at which you're ideally looking for solutions that you might take on?
Absolutely. So I think that the comment of the right thing for the right place, and there is space for everything, and it's much better to get on and do stuff rather than to sit back and wait. So there's definitely room for everybody to play. Now, Vattenfall, we tend to work at city scale, and that is our main objective. So we might start off with smaller projects, but the ultimate aim is to link all of those projects up. We absolutely want to replicate what we do in Amsterdam, for example, where we've delivered heat networks across the majority of the central city area now. And yes, that's not to say that the other options are not totally viable, but at Vattenfall we try not to be all things for all people. So we have perhaps limited our view to doing large city scale heat networks, but there's definitely an awful lot of opportunity for absolutely everything in between, from individual apartments through to regional solutions and kind of town districts.
Thank you, Andy. I've got a great question here from Margin at ChangeWorks. All the analyses and technical knowledge is impressive. What do the speakers think are the largest barriers for progress with local authorities? Do they have enough resource and capacity to take this knowledge and put it into practice? What's your take on that? Ben, let's start, given you haven't had a...
Well, I think what we've found is that most local authorities are taking a lot of the responsibility, but they don't have perhaps as clear a pathway in terms of the tools that they can use to make it happen. So they're going to be developing these LHES projects, but how are they going to be able to deliver? It's also very clear that they're expecting the private sector to come in and invest in a lot of it. So I think the biggest challenge that city centres have got is how they can prepare the groundwork. In that case, could well be quite literally, understanding what's underneath the ground, for example, in these city centres, so that when the private sector investment comes in, the risk has been reduced. So I think it's about reducing risk and improving the risk certainty for private sector investment.
Dave, you're doing lots of work with local authorities. What's your take on their challenges, I suppose?
It's a complicated bit. The short answer is no, there's not enough resource. The better answer is resource for what? We need to decide what it is we want to resource first, and then work out how we're going to resource it. Some of the detail behind the scenes, if you like, nothing will happen now that the renewable heat incentive is finished. Let's be very clear about that. The financial model for everything you've seen so far today doesn't exist anymore. It's finished. You can have better versions of not very good, and you can have worse versions of not very good. So how do you make that financial model come back again? And it's all about offtake surety. It's about deciding to stop doing the wrong thing and getting behind that. That's not something that Glasgow City Council can decide to do. They don't have the authority to utilise any mechanism to phase down gas in the city at the moment. No matter what they say about 2030 net zero or anything, they don't have the authority, because the Scottish Government doesn't have that authority, and the UK Government, who does have the authority, haven't decided what the plan is. So I think it's a wee bit unfair to jump straight to the answer of it's not resourced. There's no point resourcing something that isn't going to happen. We can do all the LHES planning, we can do all the district heat legislation and all the rest of it, but until somebody decides, as they've done in the Netherlands, and it's a bit that's forgotten in every country I always hear about, two very specific examples, there isn't a gas network across Scandinavia that is a counterfactual option. So they're starting from a completely different place. And the Netherlands, they've decided to roll back the gas network and take it away. So the question then is, what's the next best thing we can do? We have to decide we're going to do something other than burning gas, or the whole thing's a complete waste of time.
I think that's really sort of pertinent comments as we come to the end of this. Andy, Matthew, have you got any last comments before we draw things to a close around that area?
My last comment is around the climate emergency, and that you know, if there's local authorities there on this call, this is a climate emergency, and we really need to do stuff, get stuff on the ground, and you know, really get the projects on the ground in there. And this is the time where all the extra work and all the extra effort it really makes up the mileage. So you know, zero carbon heat is achievable. It does stack up, and in my view, and we definitely need to get these systems in the ground and get them there.
Thanks, Matthew. Andy, can I leave the last word to you?
Okay, so it's about having that clear direction of travel. So very clear strategy. It says this is what we're going to do. Equally, this is what we are not going to do. Trying to remove what we have at the moment, which is a lot of fear, uncertainty and doubt over mixed options, and accept that we need to make that first step and get moving with it.
Excellent, thank you, Andy. Okay, I've got a minute to bring things to a close here, so I've just got a couple of points of my own, which I will add to the guys' comments just now. To stay with Andy's sort of game analogy of his snakes and ladders, I think gigs is just one piece of what is a very complicated jigsaw. I hope it's a valuable piece. I think it's a valuable contribution to hopefully moving things forward. I think it feeds in some very useful intelligence around potential low carbon heat supply options into the process that Guy outlined into our energy master plans for our different geographic areas, whatever unit we decide on which to base those on, and our plans for LHES. So that's what I hope we've created, and by making the data as widely available in its raw form, I hope that we can empower others to take it forward and utilize it in their own way, in their own local environment and conditions, to help them achieve the goal that we're all striving towards. So our findings report will come out in May. And please, we can notify you that's come out, and it just leaves me really to make some thank yous to all the speakers today for their contribution. I hope it was really valuable for listeners, and to all the core partners, obviously, who contributed to the project. and indeed the many other partners who made valuable contributions. I want to pick out SEPA because they really helped us to address the water source heat situation and the demand, and particularly, the supply side really of the water source heat in a situation where we didn't really have any national data to support it, or we do, but it's all commercially licensed, so we can't get hold of it. So SEPA really helped us out with that, and I have to thank them for that. And finally, to Ramble for being an incredibly flexible consultant on this project, because the goalposts have moved almost the other sides of the pitch as we've gone along, and I know that there would be some that would have not responded in quite the way that they have. So for them, their flexibility and everything that they've helped us with along the way, thank you very much to their approach. I leave you with a blatant steal from my LinkedIn page from someone I was on a call with a couple of days ago called Jan Rosnow, and he said, right now we're effectively in a situation where we're taxing water and giving away fizzy drinks. And I like that, really like that analogy, because obviously the situation with electricity is it is really decarbonized, particularly in Scotland. But we're almost no taxes on natural gas at all. And although there are good reasons why that's the case, surely we've got to change that balance and readdress where the carbon is coming from. And of course, unfortunately, for some, the power to do that lies fairly and squarely at Westminster and not at Holyrood. So I hope the audience have found that very useful. Sorry, we've gone over by 4 minutes, but thank you very much for joining us, all the audience as well, and having a lot of useful contributions from you all. We will try and address all the questions individually and submit some responses to all your questions if we haven't got to them over the course of what's been a very packed schedule today. So thank you all again, and have a great rest of your day.